Hi all, welcome to goclasses. In this lecture, we will solve K-map gate CS PYQs. This is K-map gate CS PYQs part 3. The previous two parts you can find on the YouTube. You can search on YouTube K-map goclasses. Okay, on YouTube. So you will find this K-map all gate CS PYQs part 1, part 2. Both of these parts you will find if you search K-map goclasses on YouTube. Okay. Let's solve GATE 2004 question. Which are the essential prime implicants of the following Boolean function? A Boolean function f over three variables ABC is given to us, and the question is asking essential prime implicants. What are essential prime implicants for any Boolean function? Essential prime implicant EPI. This is a prime implicant which covers at least one cell uniquely. Okay, very simple. So for this question, what we will do? First, we will find the prime implicants. First, we will find all the PI. Then we will see what are the one cells which are covered uniquely by a PI. Okay, those PI will be EPI. Very simple, very easy. Okay, so let's see here. First, you make the K map. This function f a b c, here remember the order of variables is already given to you. A is most significant, c is least significant, and by default the variable order, that is basically alphabetical order. Okay, so here the variable order is given to you. Now let's see, this function f a b c is given to us. It is a bar c or ac bar or b bar c. Okay, so let's make the K map for this function. Three variable K map we are creating, and on the column let me put AB, variable AB. On the row let me put variable C. So here you have 0 1 0 0 0 1 1 1 1 0. Okay, now let's label the area also in this K map. So you can easily see that in these two columns, this variable A, that is 1, so this is area of A. Okay, you can see in these two middle columns the variable B is 1, and in this second row the variable C is 1. Okay, so you can see this is the area of C, this is the area of C bar, this is the area of A, this is the area of A bar, and this is the area of B, and this is the area of B bar. Okay, now what we will do? We will fill this K map. And remember, this SOP expression is given to you. From the SOP expression, it is very easy to fill the K map. Okay, remember this expression that is given to you, this is SOP expression, because here we are doing sum of product terms. Okay, this is a product term, product term, and this is also product term because product of literals. Okay, so you can see this is SOP expression. From the SOP expression, filling the K map is actually very easy. You see this product term A bar C. What is the area of A bar C? You can see this is A bar area. Okay, this is A bar area, this is the area of C. So you can see this is the area of A bar C. Okay, so here the function is 1. Now let's see AC bar, this product term AC bar. This is the area of A, this is the area of C bar. So what is AC bar area? This area is AC bar here area. So here also function value is 1. Now let's see the next, that is B bar C. You can see this is the area B bar, and this is the area of C. So what is the area of B bar C? So you can see these two corner cells. You can see this cell and this cell. These two will be B bar C area. Okay, so that's it. This is how you can fill the K map. Now, after filling the K map, let's find all the prime implicants. Then we will find all the EPI. Okay, so let's find all the prime implicants. First, you find PI. Okay, first you find PI, then you find EPI. So let's find the PI first. Here you can see PI. What is prime implicant? Prime implicant is a cube covering ones which is as large as possible. Means maximal cube covering one cells. Okay, maximal cube covering one cells. So here you can see, can I create any 4 size PI? Can I create any 4 size cube here? No, I cannot create any 4 size cube here. So you can see 2 size PI I can create. Okay, this PI I can create, you can see. Okay, and so this is a PI. Next you can see that this is a PI, correct? Okay, next you can see this is a PI. Okay, and this is a PI. Okay, is there any other pi? Is there any other prime implicant? No, there is no other prime implicants. So total how many prime implicants are there? The number of prime implicants. So you can see 1, 2, 3, 4. Okay, total 4 prime implicants are there. Now after finding pi, you just see what are the one cells, what are the one cells which are uniquely covered by a pi. Okay, which are only covered by one pi. Okay, so you can see, look at this one cell. This one cell is only covered by this green pi. This one cell is not covered by any other pi. So I can say that this green pi, this covers at least one cell uniquely, so this green pi will become epi. Okay, so you can see this will become epi. Okay, is there any other one cell which is covered uniquely by a pi? Yes, you can see this. This one cell is covered uniquely by this pink pi. So this pink pi, this will also become EPI. Okay. Now, is there any other one cell which is covered uniquely by a pi? So you can see this one cell is actually covered by two pi. You can notice. Look at this one cell. This is covered by green pi also and blue pi also. This one cell is also covered by two pi, this blue pi and also this orange pi. Okay. So you can see that's it. Basically this one cell, only these one cells are basically covered by a pi uniquely. So total 2 EPI we have. The number of EPI, that will be total 2. Okay, you can write the product term, that will be your EPI. So let's see for this green, for this green pi which is the EPI, what will be the product term? This is in the area of C, this is in the area of A bar, so it will be A bar C. Okay, and what about this pink pi? This is also EPI. This is in the area of A. This is in the area of C bar. Okay, A, C bar. So these are the EPIs. So remember, what are the EPIs? A bar C, A C bar. These are the EPIs. Okay, so for this question, answer will be A bar C, A C bar. So answer will be option A. Okay, very easy. I hope you understood. Let's all get 2015 question. The number of min terms after minimizing the following Boolean expression. This Boolean expression is given to us. We need to minimize it. After minimizing, what will be the number of min terms? So this question we can solve using multiple methods. Okay, let's see the method number 1. The method number 1 is basically you can just minimize this expression directly with the help of Boolean laws. Okay, Boolean rules. So with the help of them, you can just minimize this function directly. Okay, so let's do that. Now let's simplify this with the help of Boolean laws. So here you can see we have D bar here, and in here we have D. Here we have D. So if you recall, there is a rule, very simple rule, that alpha or alpha bar beta. What we can do in this expression, when we have alpha here and there is alpha bar here, then we can just remove this alpha bar and it will be alpha or beta. Okay, very simple. So this rule we can apply here. Basically, you can see D bar, we have D bar or A C bar D. A C bar D. So here you can notice that this is alpha and this is alpha bar. So what we can do? We can remove this. Okay, and what we will get? We will get D bar or AC bar. Okay, the same thing I can do when I have D bar or A bar, C bar, D. Okay, here also the same thing will happen. This D I can remove and I will get D bar or A bar, C bar. Okay, so that's the point. So you can see this D bar, and here we have D, here we have D, correct? So what I can do? I can write it D bar, or from here this D will be gone, from here this D will be gone. So I will get A B bar or A bar C or A C bar or A bar C bar. Okay, and remember there is whole bar. Very simple. So very easy, right? Okay. Now you can notice we have A C bar, A bar, C bar. So here I can take C bar out, then inside I will get A or A bar, and that will be 1. Okay, so from here I will get C bar, correct? Okay, so you can see what I will get. I will get D bar or A B bar or A bar C, or from here I will get C bar because I can take C bar out. Then inside I will get A or A bar, that will be 1. Okay. So this is what I got. Then you can see I have C bar here and here I have C. So again, this same rule I can apply. Alpha or alpha bar beta is equal to alpha or beta. Okay. So here basically the C also will be gone. So then what we will get? We will get D bar or A B bar or A bar or C bar. Correct? Okay, this is what we will get. Then here you can notice I have A bar here, I have A here. Again, this same rule I can apply. Alpha or alpha bar beta, I can remove this alpha bar and I will get alpha or beta. So here this A I can remove. And then what I will get? I will get D bar or B bar or A bar or C bar whole bar. Okay. Then finally you can apply the De Morgan law and you will get A, B, C, D. That's it. Okay. So this is what you will get. Okay. So the number of min terms after minimizing the following Boolean expression, when you minimize the Boolean expression, this F, then eventually after minimization, you are going to get F equal to ABCD. F equal to ABCD. And remember this ABCD, this is a min term because min term is a product term containing all the variables. This is a product term. This is product of literals. You can see. So this is a product term containing all the variables. So this is a min term. The question is asking the number of min terms after minimizing the following Boolean expression. So the number of min terms will be 1. Okay, you can see this is the min term we will get when we minimize this function. Okay, so very easy. So this question you can solve by this method. You can also solve this question with the help of K-map. Okay, so let's do that also. So there is method 2 to solve this question, that is K-map. So let's make the K-map here. We have this function over 4 variables A, B, C, D. By default, the variable order, that is alphabetical order. So A will be the most significant variable and D will be the least significant variable. So we have this function F, that is A, B, C, D. Okay, and this is the by default order of variables. Okay, here A is the most significant variable. Okay, most significant, and you can see this is the least significant variable. Okay, now what we will do, we will make the K map. But notice one thing here, there is a complement here. Okay, so you can see, look at this function F. This function F is basically D bar or A B bar or A bar C or A C bar D or A bar C bar D whole complement. Okay, there is whole complement. So what you can do, for a moment you assume that this inside this function is G. Okay, let's call it G. So what we will get, our function is basically G complement. Okay, so what we will do, first we will make the K map for G. Then we can easily make the K map for G complement. All we have to do, just make every 0 1 and every 1 0. Okay, yes or no? So you can see for this G you make the K map. Okay, then K map for G, and then you can easily make K map for F. Okay, so let's do it. So let's make the K map for G. Let's fill the K map for G. Now we have 4 variable K map, yes or no? So you can see this 4 variable K map we have created. Okay, now remember what is G here. Let me just quickly write it. G is basically D bar or A B bar or A bar C, A C bar D, A bar C bar D. Okay, this is the G. Now let's see how to fill the K map. Remember this G is given to you in SOP form, correct? Okay, this SOP expression is given to you because we are doing sum of product terms. You can see product term, product of literals. Okay, you can see product of literals. So all these are product terms and we are doing sum of product terms. So this is SOP expression. So remember this G, this SOP expression is given to us. SOP form. And from SOP form, filling the K map is actually very easy. First, let me label the K map. Okay, you can see this will be the area A, this will be the area B, because remember I am putting this variable AB on column and this variable CD on row. So you can see this is the area C, this is the area D. Okay, now let's fill the K map. You can see, look at this product term D bar. What is the area of D bar? You can see this is the area of D bar. Okay, so here this G will be 1. Okay, next you can see, look at this product term A B bar. You can see this is the area A. Look at this. This is the area A. And remember, this is the area B bar. So what is the area of A B bar? That will be the last column. Okay, so you can see this will be A B bar. Okay, this will be A B bar. Next you can see A bar C. This is the area A bar. This is the area C. So what is A bar C? You can see this cube, or I can say this square. This will be basically A bar C. Okay, this is A bar C. What about A C bar D? You can see this is the area A. Then what is A C bar? You can see this is the area C bar. So finally I can say that this is A C bar. And then you can see this is the area D. So I can say that this is A C bar D. Okay. Next, A bar C bar D. This is the area A bar. This is the area A bar D. Okay, A bar D. And A bar C bar D. So this will be A bar C bar D. Okay. So that's it. This is the K-map for function G. But we want K-map for function F. What is function F? What is function F? Function F is G complement. This whole thing complement. Yes or no? F is basically G complement. Okay. So when you make the K-map for F, then what will happen? Wherever G is 1, their F will be 0. And wherever G is 0, their F will be 1. So remember, all these 1, you just make them 0. Okay. For F. Because F is G complement. So where G is 1, F will be 0. Where G is 0, F will be 1. Okay, so you can see, and you can see for this cell, G is 0. So here F will be 1. Okay, that's it. Now you can easily notice this is the K-map for function F, and I can write the expression for F, the minimized expression for F. What will be minimized expression for F? You can see there is only one cell. I need to cover it, and then I will write the product term for this. So this is in the area of A, this is in the area of B, this is in the area of C, comma D. So that's it, A, B, C, D. This is the minimized expression for F. And in this minimized expression, we have only one minterm, because minterm is a product term containing all the variables. Here you have this product term containing all the variables. So this is a minterm. So for this question, answer will be the number of minterms after minimizing the following Boolean function, that will be 1. Okay. Very easy. I hope you understood. So this question you can solve by multiple methods. Remember, most of the questions in Boolean algebra, in digital logic, you can solve by multiple methods. Okay. So you should understand all the methods. Then you can decide which method is more efficient for which question. Okay. For different questions, different method will be more efficient. So you should understand everything. Understanding everything will give you more perspective. Okay. So you can solve any question using the most efficient approach. That is the benefit. Okay. Let's solve GATE 2025 question. Let X be a 3 variable Boolean function that produces output as 1 when at least 2 of the input variables are 1. So X is a Boolean function over 3 variables, and this is the definition of X, that the output of X will be 1 when at least 2 input variables are 1. Okay, so I can say this is basically majority function. This is also called majority function, means when the majority of the inputs are 1, then output will be 1. Okay, otherwise the output will be 0. Okay, which of the following statements is or are correct where A, B, C, D, E, these are Boolean variables? So this is a MSQ question, means one or more options can be correct. Okay, This question we can solve by multiple methods. The first method, that is less efficient, but that will come to your mind very quickly. Okay, that is basically we write the expression for x, then we write expression for LHS, then we write expression for RHS, and then we see whether LHS is equal to RHS or not. Yes or no? This is the method that will come to your mind when you see this question. But actually that will be less efficient. That will be time consuming. You can see you will have to check all the options, all the four options, and for every option you have to write LHS also, RHS also. Okay, and you can see that will consume a lot of time. Okay, so there must be a efficient method. What is efficient method? We have already seen in our go classes lectures. There is a method which I think only go classes teaches, and that has become favorite of most of the students. Do you remember that method? By case method. Whenever you have this type of situation where you have many boolean variables, then always use by case method. Okay, and remember, you don't have to create by case, you don't have to create cases only for one variable. You can create cases from two variable point of view, because look at all the options. In all the options you can see that I can create cases from AB point of view. Okay, you can see, look at all the options, option A, B, C, D. On the LHS you can see I can create cases from AB point of view. When I create cases from two variable point of view, then total four cases will be created. Yes or no? Because these two variables AB, they can be 0 0, they can be 0 1, they can be 1 0, or they can be 1 1. So total four cases will be created, and then you can very easily, very quickly solve this question. Okay, so let's solve this question by two methods. The first method, that is by case method, that is efficient method, that is smart method, and that you should apply. You should think about by case method whenever you see this type of complicated question, whenever you have more number of variables. At least think about by case method. Okay, this I told you many times also. And also then we will solve this question by the method 2 also, that is less efficient, but that will come to your mind very quickly. Okay, most of the students will think about that method. Okay, so first you understand this function f. Let's understand this function x here. So this x, this is a function, this is a boolean function over three variables, and the definition is that it will produce output as 1 when at least two of the input variables are 1. So please understand that this x, when at least two variables, when at least two input variables are 1, then the output will be 1. Very simple. Okay, so you tell me, if I have this situation, then if all the input variables are 0, then here you can see that the output will be 0. Okay, because the output of x will be 1 when at least two input variables are 1. Okay, so you can see here also the output will be 0. Okay, here also the output will be 0. If you notice, for how many input combinations output will be 0? Only these are the four input combinations where output will be 0. For all the remaining input combinations, the output actually will be 1. Okay, you can see whatever remaining input combination you take, the output will be 1. Okay, so you can see. Okay, like that, and so on. So I hope you understood this function. So first you understand the function x. Okay, now let's see this option A, option B, option C, option D. One by one, we will see all of them. But remember, we are going to apply the by case method. Okay, so the method 1 that we will apply, that will be by case method. And after this question, this by case method will become your favorite, because it will save a lot of time. When other methods are time consuming, then this by case method, in most of the situations, this will save a lot of time. Okay, so remember here, in this by case method, either you can create cases from one variable point of view, or you can create cases from two variable point of view. Okay, so remember, if you create cases from one variable point of view, okay, for example, let's assume we have a boolean variable. Let's assume we have a boolean variable a. Okay, so from this boolean variable a point of view, I can create two cases because either this variable will be 0 or this variable will be 1. There is no other possibility, yes or no? So remember, there will be two cases. The case 1 will be when this variable is 0, and case 2 will be when this variable is 1. Only two cases are possible. There is no other case possible, yes or no? And remember, from two variable point of view, if I create by case, okay, if I create cases from two variable point of view, so let's take variables AB. Okay, so from two variable point of view, I can create total four cases. I will create, yes or no? Because these variables AB, they can be 0 0, they can be 0 1, they can be 1 0, they can be 1 1. Correct? So remember, total four cases will be there from two variable point of view. Okay, here you can see both A comma B are 0. Here A is 0, B is 1. Please understand what this means. This means A is 0, B is 1. And what this means? This means A is 1, B is 0. And here both are 1 1. Okay, yes or no? So let's see here. In this question, look at all the options and look at the LHS. Then you will see that creating cases from two variable point of view, that will be better, yes or no? You can see in all the options on LHS you have AB. Okay, so basically creating cases from two variable point of view will be better. Okay, so let's create cases from two variable point of view. So this is option A. Remember, for every option we will try to find a counter example. If I can find a counter example where LHS and RHS, they are different, okay, then that option I can eliminate, yes or no? Because this is MSQ question. For every option I will try to find a counter example. And remember, if I cannot find a counter example for some option, then that option will be correct. Very simple. Okay, so let's see this option A. In this option A, I will create cases from variable AB point of view. Okay, so total how many cases will be there? Total four cases will be there. Okay, so remember, I will create by case method. I will apply by case from variable AB point of view. Okay, so total how many cases? Total four cases will be there. You can see variable AB can be 0 0, variable AB can be 0 1, variable AB can be 1 0, and variable AB can be 1 1. Okay, so let's see here. You can see I will try to find counter example for option A. Here you can see if AB is 0 0, if I put AB 0 0, okay, AB 0 0 means on the LHS also, on the RHS also, if I put AB 0 0, then what will be LHS? If I put 0 0, then whatever this third entity be, yes or no, this LHS will be 0. Do you agree with me? If I put AB equal to 0 0, then you can see for this function X, there are three inputs. And you can see if AB is 0 0, then whatever this third input be, you can see this LHS, this overall, this LHS will be 0. What about RHS? If I put AB 0 0, then you can see if I put AB 0 0, then this first input, this will be 0. Yes or no? Definitely this first input will be 0. But remember, still I can make this RHS 1 because I can make this DE equal to 1 1. Yes or no? If I make DE equal to 1 1, then this RHS will become 1. Do you agree with me? Remember, for this AB 0 0, this first input will become 0. Okay, because AB 0 0, so this X will become 0. I can say this will become 0. But if this D comma E, if they are 1 1, then this RHS will become 1. Yes or no? Okay, do you agree with me? So finally I can say that here I got a counter example. Okay, if I put AB equal to 0 0, and if I put D equal to 1 1, then RHS will be 1 and LHS will be 0. Okay, did you get it? So you can see AB equal to 0 0, LHS will be 0, and RHS will be 1 when DE equal to 1. Okay, so that's it. I can just eliminate this option A. This option A has been eliminated because I found a counter example. Okay, is this clear to everyone? I don't have to check the remaining three cases. There is no need. There is no need. There is no need to check, because you can see when because you can see that overall I can say that when a0, or I can say a b c d e is equal to 0 0, c can be anything. Okay, you can take c to be anything, that really doesn't matter. Okay, c can be anything, and then d, that is 1 1. Okay, so when you have this situation, then in that case LHS will be 0 and RHS will be 1. So definitely LHS, RHS, they are not equal. Yes or no? So option A has been eliminated. Okay, very simple. Let's see option B now. Let's check option B. Again, we apply the by case method. We create cases from variable AB point of view. So total 4 cases we will create. Correct? Correct. So again, we will apply the by case method. And in this by case method, variable AB point of view. Okay. So you can see from variable AB point of view. So total how many cases we will create? Total 4 cases we will create, correct? Okay. So the 4 cases, these will be AB 0 0, means both are 0. Then AB 0 1, then AB 1 0, and then AB 1 1, correct? Now let's see, when AB 0 0, then what will be LHS? AB 0 0, then you can see whatever this third input be, already AB is 0 0, two inputs are 0 0, then whatever this third input I put, then you can see this LHS definitely will be 0. Okay, yes or no? Next, what about this RHS? When AB 0 0, then whatever this third input be, you can see this RHS also will be 0. So far, I cannot eliminate option B. I did not get any counter example. Okay, now let's see this case AB 0 1. So when AB 0 1, then what will be LHS? You can see AB 0 1 means this B, this is 1, A is 0. Okay. Now remember AB 0 1, AB, here also we have AB. So here AB 0 1. Now in this case, I can say it will depend on C. Do you agree with me? Okay. Notice if I put AB 0 1, then what will be this value? That will depend on C. If C is 0, then this value will be 0. If this C is 1, then this value will be 1. Do you agree with me? Tell me, did you understand that when I put AB 0 1, okay, AB is 0 1, then if this C is 0, then this overall output will be 0. If this C is 1, then this X will be 1. So can I say that I can say that this X is basically this is same as C? Yes or no? This will become same as C. Here I can write C. Now again, here A is 0, B is 1. So again, you can see if this C is 0, then this LHS will become 0. And if this C is 1, then this LHS will become 1. So this LHS is same as C. Can I say when AB is 0 1, then LHS will be same as C? Okay, let's look at RHS, what it will be. You can see if I put AB 0 1, then you can notice if C is 0, then this RHS will be 0. If C is 1, then RHS will be 1. So I can say RHS is also same as C. So here also I cannot eliminate option B. Yes or no? I have to check these two cases also. Let's check when AB equal to 1 0. When AB equal to 1 0, the same situation will happen which has happened in AB equal to 0 1. Okay, you can see LHS will also become C, RHS will also become C. Okay, because you can easily do it. AB equal to 1 0 means A1 B0. A1 B0. Now notice one thing. If C is 0, then this third component will become 0. If this C is 1, this third component will become 1. So can I say this third component is same as C? Yes or no? C0 third component 0, C1 third component 1. So I can say this third component, this is same as C. Now you can notice that because AB is 1 0, so here also you have 1 0 C, here also you have 1 0 C, so LHS equal to RHS. Yes or no? You can notice here also you have 1 0 C, here also you have 1 0 C, so LHS equal to RHS. Or you can think like this, that now notice, if C is 0, then this LHS will become 0. If this C is 1, then this LHS will become 1. So I can say this LHS is same as C, correct? And similarly, you can see that RHS also will be same as C. So here also I cannot eliminate option B. Now I have to check this fourth case also. AB equal to 1 1. Tell me, if AB equal to 1 1, now this LHS value does not depend on the third component. Third component can be anything. This LHS will become 1. Here also you can see when AB equal to 1 1, then this RHS does not depend on C. The RHS will be 1. Okay, so I can say that LHS also will be 1, RHS also will be 1. Now, notice one thing, that in all the four cases, LHS, RHS, they are same. And remember, only these four cases are possible because from two variable point of view, only these four cases are possible. There is no other case possible. And in all the cases, option B has LHS equal to RHS. So I can say that option B is valid. Okay, option B is definitely valid. What about option C? This is option C. Again, we create by case. From two variable point of view, I create cases. Okay, so again, by case method we apply. From variable AB point of view. Okay, again, there will be total four cases because from two variable point of view, there will be total four cases. AB 0 0, AB 0 1, AB 1 0, AB 1 1. Okay, now let's see here. When AB is 0 0, then what will be this LHS and what will be RHS? I will try to find counter example. Remember, for every option, I'm trying to find counter example. Okay, so you can see where AB is 0 0. Now, whatever this third component be, this LHS definitely will be 0. Yes or no? LHS definitely will be 0 because AB is 0 0. Two variables, two input variables are 0 0. Then this third component can be anything. This LHS, this overall, this LHS, this will be 0. And what about RHS? When AB 0 0 means A and B both are 0 0, then you can see this will be 0. 0 and anything that will be 0. Okay, so you can see RHS also will be 0. So remember, right now, so far, I cannot eliminate option C. I have to check the remaining cases also. When I have AB equal to 0 1, AB equal to 0 1. Now, in this case, this A is 0 and B is 1. A is 0, B is 1. Okay, notice one thing, that this will become 0. 0 and anything that will be 0. So definitely RHS is 0. Yes or no? When AB is 0 1, definitely RHS is 0. Okay. Now, what about LHS? Can I make it 1? Can I make this LHS 1? A is 0, B is 1. A is 0. So tell me, can I make this LHS 1? Yes, I can make it 1. I can make CD 1 1. If I make CD 1 1, this third component will become 1. Yes or no? This third component, this function x, this will become 1. Then you can see these two components will be 1. So I can say this LHS will become 1. Okay, do you agree with me? So I can say that LHS will become 1 when I make CD equal to 1 1. Yes or no? But remember, RHS is 0. So here I got my counter example. Okay, I don't have to check these cases. There is no need to check. I already got my counter example. So the counter example that I got, what is that? You can see when A, B, C, D, when these four variables are 0 1 1 1, then you can see that LHS will be 1, RHS will be 0. Okay, so definitely option C I can eliminate. Okay, very simple. What about option D? Let's take option D. Again, from two variable point of view, I will create cases. 4 cases will be there. Okay, so again by case method we will apply from AB variable point of view. Okay, AB 0 0, AB 0 1, AB 1 0, AB 1 1. Now, if I put AB 0 0, then what will be LHS? LHS definitely will be 0. Okay, whatever this C I put, then this LHS will be 0. Correct? What about RHS? You can see if I put AB 0 0, this A 0, then you can see that the second component also will become 0. Correct? So you can see first and second component will become 0. So this RHS also will become 0. So right now I cannot eliminate option D. Correct? When AB 0 0, then both LHS RHS they are 0. What about this case? Means A is 0, B is 1. Now it will depend on C. The LHS will depend on C. If C is 0, LHS 0. If C is 1, LHS 1. So I can say that LHS will become same as C. Correct? Okay. Now let's see RHS. So you can see this A0, A0, B1, A0. Now notice one thing here, that A is 0 and both components here are C. Okay, look at this X. Here you can see the second and third component they are C. So if C is 0, this third component will be 0. If C is 1, this third component will be 1. So this third component is same as C. This third component that is same as C. Correct? Okay, so remember this, that third component is same as C. Now, what about this second component? Here you can see that if C is 0, this second component 0. If C is 1, second component 1. So second component is also C. Third component is also C. Correct? Yes or no? So remember, this second component also C, this third component also C. Now notice, I have X 0 C C. Again, if C is 0, RHS 0. If C 1, RHS 1. So I can say that RHS is same as C. Correct? RHS has also become same as C. Very easy. Now let's see this case when AB is 1 0. If I put AB 1 0, again this LHS will depend on C. If C is 0, LHS 0. If C 1, LHS 1. So you can see that when AB 1 0, then LHS will be same as C. Okay. What about this RHS? A is 1 and B is 0. A1, B0. A1 and B0. Okay. Now let's see here. Look at this third component. If C is 0, this third component will be 0. If C is 1, the third component will be 1. So the third component is same as C. Okay. What about this second component? You can see if C is 0, second component 0. If C is 1, second component 1. So this second component is also same as C. Now I have 1 C C. Again, if C is 0, then RHS 0. If C is 1, RHS 1. So RHS is basically same as C. Correct? Okay, so what I got? I got RHS also C. Let's see the last case. When AB are 1 1. If I put AB 1 1, then whatever this C, this LHS will be 1. Correct? Okay. Now let's see RHS. When AB 1 1, A is 1, B is 1. Now notice the second component will be 1. Whatever C value I put, then the second component will be 1. Now these two components are 1. So RHS will be 1. Okay. So that's it. RHS is also 1. Okay. So finally I can say that In all the cases, LHS, RHS, they are same. So I can say this option D, that is also valid. Okay, option D is also valid. Is this clear to everyone? Let me know. So this is a beautiful question. To be honest, this is beautiful question. And one more thing, I am explaining, that is the reason it is taking time. It will not take time if you do it yourself. You just use the by case method. From two variable point of view, you create cases. Here you can see from AB variable point of view, you can create cases. Four cases will be there. And very easily you can solve this question. You just try to find the counter example. In every option, you try to find the counter example. Okay. And it's not very hard, I can say. This question is very beautiful question. It's a creative question, beautiful question. And many students, they will waste a lot of time in this question if they apply some inefficient method. This method, this by case method, because I'm explaining, so it is taking time. If you do it yourself, it will not take time. Okay. Now remember, there is another method to solve this question. What is that? That is, you write the expression for x, then you write expression for LHS, RHS in all the options, and then you check. Okay, that will be a time taking method, but let me show you how to do it. First, I will write the expression for x. What is x? X is a function over three variables. So let's see what will be x abc, or let's see what will be x pqr. Okay, so what will be x pqr? Already the definition is given to you. X is a Boolean function over three variables that will produce 1 when at least two input variables are 1. Okay, so you can see when at least two input variables are 1. For example, if PQ is 1, then X will be 1. Now, R, it does not matter what is R, yes or no. When at least two variables are 1, then X will be 1. So you can see if PQ is 1, PQ, both are 1, 1, then it does not depend on R. Yes or no? So I can say PQ. Or if QR is 1, 1, then it does not depend on P. If PR is 1, 1, then it does not depend on Q. This will be the expression. Okay, is this clear? Very easy. I hope you understood. Did you understand how to write this expression? If you did not understand, you can also write this expression from truth table. Okay, so either you create the truth table, then you write the expression for X, or you can write the expression for X from K-map. Let me write the expression for X from K-map. PQR. Okay. So this variable PQ I'm putting on column, and this variable R on row. Okay. Now you can see the definition of X you already know. X will be 1 when at least two input variables are 1. So where in these cells where we have at least two input variables 1, here you can see at least two input variables are 1. So here X value will be 1. Correct? Okay. Let's see. Here all the input variables are 0. Here only one input variable is 1. Here only one input variable is 1. But look at this. Here two input variables are 1. Here two input variables are 1. Okay. So this will be the K-map for X. For this function X, this will be the K-map. Now from K-map, you can write the expression for X. You can see you will create the cubes like this. If you want to write SOP expression, then you will make cubes covering ones, and for every cube you will write product term. So what are the areas? Let me mark the areas. You can see this is the area P, this is the area of R, and this is the area of Q. Okay. So for this yellow cube, what will be the product term? This is in the area of QR. Okay. For this orange, what will be the product term? This is in the area of PQ. And for this pink, you can see this is in the area of PR. Then you can finally see that X is equal to PQ or PR or QR. Okay, is this clear? The same thing we got here. Actually, you don't even have to create truth table. You don't have to create K-map. Okay, from the statement, you can easily write the expression, because the statement is saying that X is a Boolean function over three variables that will produce output 1 when at least two input variables are 1. So you can see if PQ are 1, If PQ both are 1, then X will not depend on R. Yes or no? X will be 1. So you can see PQ. Similarly, if QR are 1, then also X will be 1. If PR are 1, then also X will be 1. So PQ or QR or PR means at least two input variables. If they are 1, then X will be 1. So that's it. Now you can see this is the expression for X. Now you can check all the options one by one. Okay, let me check option A first. Let's check option A. Option A is saying XAB, XCDE, XAB, XCDE. This is equal to XABCD, X. You can just see this method will take a lot of time. It will consume a lot of time. What is the reason? Because you can see first you will write this XCDE. What it will become? It will become CD or DE or CE. Then you will write this expression. Yes or no? It will consume a lot of time. Do you agree? What will happen? What this LHS will become? It will become AB or A, this third component, A. And what is this third component? Let me write this third component. This third component is basically CD or DE or CE. Okay? Or B and this third component. Okay, so you can see B and again this third component, that is basically CD or DE or CE. So this is the LHS. This is only the LHS so far. Now you have to write RHS also. What this RHS will be? This RHS will be this first component with D, first component with E, then DE. Okay, so you can see in this RHS what you will get? You will get DE or this first component, that is basically AB or BC or AC with D, or AB or BC or AC with E. Okay. Now what you will do? Now you will check, is LHS equal to RHS or not? Is this method painful? Do you think? After seeing the previous method, by case method, do you think that this is painful? If you apply this method, even if you get the answer, even if you get the marks, you will cry, I think. You will be sad that you applied this method. You will be very sad. Okay. So you can see this is very painful method and I really don't want to continue. Okay. But let's see this option A. At least you can notice one thing here actually, that here I have AB and on the RHS actually I will not get AB. Okay. You can see. Now actually again, this is not enough basically. On the LHS I have AB and on the RHS I will not get AB, but that is not enough. Maybe if I simplify RHS, maybe I will get AB. I don't know. Yes or no? Do you agree with me? Okay, I don't know what will happen after simplification. Eventually, I have to find the counterexample. Either I find counterexample or I prove that both are equal. Do you agree with me? So I have to either find the counterexample or I have to prove that both are equal. Correct? So you can see here actually I can find the counterexample. What I can do? On the LHS I have AB or something something something. So if I put AB equal to 1 1, just notice, if I put AB equal to 1 1, then what will be LHS? LHS will be 1 because on the LHS I have AB or something something something. 1 or anything, that will be 1. So if I put AB equal to 1 1, LHS will be 1. What about RHS? If I put AB equal to 1 1, then RHS will be DE or. You can see if I put AB equal to 1 1 1, then this will be 1. 1 or D, that will be D. This also will be 1. 1 or E, that will be E. You can see here I can apply the absorption property, absorption law. So overall I will get D or E. You can see LHS and RHS, they are not equal. LHS is 1, RHS is D or E. So definitely they are not equal. So I can eliminate option A. Okay, is this clear? This is how I can eliminate option A. Now, similarly, you can do option B, C, D, that I leave up to you. But I think for this question, the best method is by case method. You create cases from two variable point of view. Why I am creating cases from two variable point of view? Because total I have five variables. So if I create cases from one variable point of view, then after creating cases, again I have to deal with four variables. Do you agree with me? If I create cases from only one variable point of view, let's assume a equal to 0, a equal to 1, then after creating the cases also, I have to deal with four variables. So what I can do, I can create cases from two variable point of view. I can create cases from AB variable point of view, because in all the options, you can see here, this AB, 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 this is fixed. Okay, so from AB variable point of view, I can create the cases, and then I can easily solve this question. We have already done the complete analysis in this session. Okay, I hope you understood. A student has given a brilliant suggestion. See, in the option D, it is much better if you create cases from AC variable point of view. Okay, so a student Priyans has given this suggestion that in this option D, what you can do, notice in this option D, which variables are most appearing. You can see A comma C, they are most appearing, yes or no? ACC, AC, AC, AC. So the variable which is most appearing, from those variables point of view, you can create cases. In this option D, you create cases from AC point of view, means AC00, AC01, AC10, AC11. Is this clear, everyone? Remember, you don't have to create cases from AB point of view. You can create cases from any two variable point of view. So you find those two variables which are most appearing. You can see in option D, A comma C, they are most appearing. So you can create cases from AC point of view. That will be much better. Okay. Now, if I create cases from AC point of view, when AC equal to 0, 0, what will be LHS? What will be RHS? Let's quickly see. When AC is 0, 0, then LHS will be 0, because whatever B I put, this LHS will be 0. And you can see when ACR 0, 0, then you can see that this third component will be 0, this second component will be 0, first component will be 0. Okay, so this RHS also will be 0. When AC is 0, 1, when I put AC 0, 1, then this third component will be 1. Yes or no? Because A is 0, C is 1, so this third component will be 1. When AC is 0, 1, then in that case, what about the second component? When AC is 0, 1, then it will depend on B. So the second component will be same as B. If B is 0, second component 0. If B is 1, second component 1. So overall, this will become A, B, A is 0, remember, A is 0. So overall, this will become 0, B, 1. Okay, yes or no? X 0, B 1. And the same thing, LHS will also become 0, B 1. So LHS, RHS again are same. Okay, so like this you can do. When AC is 1, 0, when AC is 1, 1, you can check. Okay, and you can see in this option C, from AB point of view, you can create the cases because they are most appearing AB. So from AB point of view, you can create cases. In option B also, from AB point of view, you can create cases. Okay, they are most appearing AB. Okay, so I hope you understood this point, that you can create cases from those variables point of view which are most appearing, so that when you create cases, then all those appearance will become constant. Okay, yes or no? When you check for any case, then all those appearance will become constant. So you always create cases from those variables point of view which are most appearing, or I can say those variables whose appearance is maximum. Okay, from those variables point of view, you can create cases. Okay, so that's enough for this session. In the next session, we will continue these PYQs. So basically, that will be part 4. Okay, K-map, gate PYQs, gate CS PYQs, part 4. In that session, we will solve the remaining PYQs. Not a single PYQ I will leave. Okay. Okay. Thank you, everyone. Please share your feedback in the comments. Okay, please like this session and please let me know your feedback in the comments. Okay, thank you.